Hello, AP Statistics students. Happy Friday to you. Happy Friday. Hopefully, this is the last day I am out, and hopefully I'll be back with you on Monday. But if not, we'll figure it out. But happy Friday to you. We got something to take a look at today. We're moving on a little bit away from proportions. Remember, we've been doing sampling distributions for proportions. What about means? All right, time to look at means instead of proportions. There are many similarities, so in many ways you're not learning something new. There are a couple slight differences, but the overarching ideas and concepts are the same, which should be pretty nice for us. All right, so proportions versus means. What does this difference boil down to? So the first question I hear, what proportion of students at Edison did their homework last night? Well, that type of question is categorical, isn't it? You either did your homework or you did not do your homework. You got those two categories. And because it was you either did do your homework or you did not, all the math is based off the binomial. All right, that's where we got our standard deviation, and we use the binomial and the conditions that make it normal. So yes, we didn't actually use the binomial. We just made sure all the conditions were checked off to make the binomial normal. But like the standard deviation and all that math was based off of the binomial. All right, but what if I ask this next question? What is the average GPA of students at Edison? Well, this is no longer categorical, is it? This is quantitative. All right, we have a quantitative variable, a continuous quantitative variable, actually. So what about this? What would the math here be based off of? Well, we're going to take a look at some of this math. It's not quite the binomial, but overall the themes are very similar. All right, so let's take a look at our three S's here, shape, center, and spread. What will these look like if we take a sampling distribution? Remember, a sampling distribution is where each dot represents a sample. All right, well, the shape, all right, to be determined. All right, stay tuned. We'll get there. We'll get there. You're actually going to investigate the shape for us here in a minute. The center. Well, the center of a sampling distribution. So if I take the average of all of the sample averages. All right, X bar is the sample average, right? So if I take the average, mu, of all the sample averages, what will that be? Well, that will be the population average, the true average, the parameter, because averages are unbiased. Remember, averages are unbiased estimators. And so, yes, the center of the sampling distribution will, in fact, be the population average. All right, because averages are unbiased estimators. So as we're building our sampling distribution here, we know the center is going to be at the true population average, mu sub x. All right, where you've got all your x bars, your x, not hats, that was for proportions. All your x bars are in here making some kind of shape that we're going to look at in here in a second. All right, what's the spread? All right, so the spread is a nice, easy formula. So the standard deviation of all the x bars, all right, all the sample averages, is equal to the standard deviation of the population over the square root of n, the sample size. All right. So again, we see a similar algebraic idea here that as sample size increases, the standard deviation gets smaller. You're going to see that graphically here in a second. Okay? But that's a formula that we are going to want to put a box around so you can come back to it over and over and over again. All right, let's do a few of these, make sure we've got this. Been to the movies recently? Actually, I haven't, oddly enough. All right, the number of movies viewed in the last year by students at a large high school has a mean of 19.3 movies with a standard deviation of 15.8 movies. Suppose we take, so those are our population parameters, 19 and 15 for the standard deviation. Suppose we now take a sample of 100 students from this school and calculate X bar, the average number of movies viewed by the members of the sample. Identify the mean of the sampling distribution. All right, so again, this nice and easy here. The mean of the sampling distribution of all the X bars, the average of all the X bars, should be the true parameter. And they told us the true parameter, it was 19.3. All right, calculate and interpret the standard deviation of the sampling distribution of X bar. Verify the old 10% condition. We are still sampling without replacement, so the 10% condition does not go away. All right, so the standard deviation of all the X bars is equal to, all right, the standard deviation of the population divided by the square root of n. So this will be 15.8 divided by the square root of 100, because we are taking samples of 100, is equal to, well, we can do this in our head actually, can't we? 15.8 divided by 10, and then that just moves a decimal place over, so 1.58. All right, those do have units, don't they? I should put the units. Those are both measured in movies. All right. There we have it, the mean and standard deviation. Now, wouldn't it be nice if I could ask you a probability question here? Hey, what are the chances that I get a sample where the average is only 17 movies on average? What are the chances I get a sample where they have seen 20 movies or more? It'd be nice if I could ask you those questions, but I can't ask you those questions until we have the shape. It's got to be normal. All right, we got to show when will a sampling distribution of means be normal. If we can make it normal, we can do all our math, right? So we need to know, when is this sampling distribution normal? We know when a binomial is normal, right? N times P, N times Q had to be bigger than 10. That made it normal. Boom, normal CDF. But what makes this normal? So I've got an applet for you to click on here. Shape. It depends, just like it depended for the binomial and for categorical variables. So this OneNote should be shared out to you if you haven't found it already. Click on this link right here. Head over to this website here, onlinestatbook.com. Good stuff. And you're going to click begin to start the simulation. All right, if you want to read the rest, you can, but click begin. It's fairly intuitive. We've got ourselves a population right here. We are going to take a sample, and then we are going to find the sample statistic, the average. And you can change the sample size right here. How big do you want the sample size to be? And you can either animate it. So I'm going to animate a sample of 5. Click, click, 3, 4, 5. There's our sample. And here's our sample statistic, the average. This is the sampling distribution, right? Where one dot represents an entire sample. In this case, a sample of 5. All right, so I'm going to do one of these boxes for you, and you're going to investigate the others today to find out what's happening with the shape. Okay? So I'm going to start out with normal here. I'm going to take a normal population, and from that normal population, I'm going to grab sample sizes of 5 and see what happens. Okay? All right, so I'll do one more animation here for funsies. We take our 5 for our sample, and we get a sample average. Of course, I want to do this many times. What does the sampling distribution look like? All right, I'm going to do the 10,000 a couple of times. Look at that. So I can either fit a normal curve over it to see that, yes, the normal curve fits over that perfectly, right? The normal curve fits perfectly. Even over here on the left, it gives me some summary statistics. The average was 16, and the average of my sampling distribution is also 16. Its averages are an unbiased estimator. They're centered over the true parameter. The standard deviation is 2.23. The old standard deviation was 5. So yes, you see that it does decrease the standard deviation there for the sampling distribution. All right, so the sampling distribution was normal. If you want to draw a picture, you can. Let's see. The other thing I want you to look at is that what happens to the standard deviation. This was 2.23. And so you can then track that as it goes. All right, let me do one more here for you. Let's do a skewed one. Let me show you how to do skew on this. So I'm going to clear everything out. So right here, it says normal at the top. There's some other ones you can take a look at. Skewed. It makes a skewed graph for you. Now that one's skewed to the right, but this is kind of cool. You can also draw your own. So if you click and drag, you can make your own. So I'm going to make a skewed left. There we go. So again, if you click and drag, you can change the population however you want. All right, so what's going to happen to my sampling distribution if I have a heavily skewed left graph? All right, so again, I take a sample, I get the sample statistic, I'm going to do lots at the same time. We get it here, and it's not bad, I know, right? It's not bad, but it is still skewed to the left a bit. All right, we still have a decent, and you can see the normal. It doesn't fully fit the normal here. There's actually even a number for skew right here. Our skew is negative 0.3, negative to the left. We do have a negative skew here. So we did a skewed left population, N of 5. So this is still, our sampling distribution is skewed left, not very much, but a little. And the standard deviation was equal to 3.48. All right, so I want you to sort of look at all the other scenarios, okay? Look at all the other skewed left scenarios. What happens if I take that skewed left population and I increase the sample size? And I increase the sample size. What happens to the sampling distribution? All right, hint, hint, we want it to be normal, right? Once it's normal, once I know the conditions for it to be normal, then I can do normal CDF for days, and it's all good. I don't have to worry about the shape. The shape will be normal. So I want you to fill out this sort of graphic organizer, fill out this table, so you can figure out when it is normal, okay? Then I have a quick Desmos summary for you to summarize your findings. It's just like 2 slides. You're going to write a couple sentences and share your ideas with the class so you can all come to the same conclusion, I hope. Okay? That's what your task is today, is to fill that out and to fill out the Desmos slide. Again, I think it's 1 picture slide and 1 slide where you have to write something, but then you do need to share it with the class. That's all I got for you today, everybody. We will pick up this where we leave off on Monday, and hopefully I'll be there. Hopefully I'll be there. Have a great weekend, everybody.